Of all the applied mathematics, statistics is probably the one that you use the most. And again, I kind of feel sorry for girls in future years because I'm going to use COVID-19 as just example after example, but it really is a timely thing at the moment. Government's collecting masses of statistics on the population at the moment, and that will shape really what their policy is going to be moving forward and trying to get out of this situation that we're in. So what statisticians do, we analyze data, or we perform an analysis of data, and that plays a crucial role in everyday life. You'll be doing it intuitively and you don't even know it. And what we do is we make decisions on those findings. And a couple of examples here: marketing gets feedback about consumer spending habits collected from online browsing. And so you'll have noted something like, if you do a Google search for something, often that will end up being an advertisement on your Instagram feed, or whatever form of social media you're on. It's used to shape public policy. So we collect this census every, I don't know how many years, 4, 6 years, I don't know how often it is. And then government departments use that to work out how to spend the taxes that they collect, or the money that they have, on either health. Do we put doctors in remote areas? Do we open up new schools? Or other public policies, how to decide what roads to improve. And politics, and what political parties do is find out, how to actually advertise to particular types of people. And you'll notice that political campaigns are marketed or done very differently, but depending on where the actual voters that they're targeting are. So rural voters will receive different ads to, say, city voters. What we need to do is carefully analyse and test the data so that we can make the best possible decision, or get the best, what we say, bang for buck. So if I've got this money to spend, what's the best way to spend it so I can hit the most amount of people most effectively? All right, so how do we grab data? What we can do is do surveys, and yeah, you'll have done bucket loads of those in your time already. What you can do then is, when you survey, you can get information from the population. So a group of people, animals or objects with something in common, all students in the school, all cars in Melbourne, all the people in Australia on census night. That's not often feasible. Okay, so when we're looking at the population, we can't often go, all right, I want to survey everyone in Australia, because there is 25 odd million people in this country. So what we often do is take a sample, okay, and that is, we choose a random group of people, or a random sample, and only ask them. And what we hope is that if we've chosen a random sample, then the data is often a good representation of the entire population. So for example, if we were looking at Sacre-Cœur and looking at favourite music genre, and the only people I surveyed were the staff members over 40, what we'd have is a situation where, we would be telling the public that the favourite artist of people at Sacre-Cœur is Cat Stevens, or Simon and Garfunkel, or something like that. So we've got to make sure that that sample is random, so that it includes, say, someone like me, someone like Mr. Kruger, but also a Year 7 kid, a Zhuani kid, et cetera, so that we get a good representation of Sacre-Cœur that we can then generalise our findings from. Okay, so when we collect data, it's really, really important to be able to classify that data. And data can either be categorical or it can be numerical, okay? Now, just because it's a number doesn't necessarily mean it's numerical data. And I'll talk a little bit about that in a sec. All right, so what we're looking for in categorical data is 2 further splits of categorical data. I can't say that word. All right, so categorical splits into nominal and ordinal, okay? And these are categories that have no order. And an example of that is like me asking you guys your favorite color, because there's really no order to that. You just nominate what your favorite color is. And that's hence the word nominal is from nominate. Okay, so you nominate what your choice is. Hands up if you've got, say, red hair. Hands up if you've got brown hair. Hands up if you've got no hair, in my case. So that's what nominal is, okay? And there's no kind of order to the categories. They just are a category. Right, and ordinal data can be ordered in terms of some gradation, so low, medium, high, okay? So it might be, how tired are you feeling today? And my levels are low, medium, and high, okay? Well, that's a category you're in, because if I asked you guys, all right, hands up girls who are tired today or have a low level of tiredness, you would nominate that that's you. But these nominations, okay, have some order to them. Okay, so that's categorical data. So now on to numerical data, and that can be split into what we call discrete or continuous. Okay, now the way to think about discrete, I always think about it as this stuff is counted. Okay, whereas continuous is measured. All right, so examples of discrete data is number of children in your family. You'd be like, okay, there's mum, there's dad, there's brother, there's sister, and there's me. That's 5. Okay, so you'd count it. The number of cars in the staff car park, I'd go down and go, that's 1, 2, 3, 4, 5, etc. And for continuous data, data can take any value within a given range. For example, time taken to complete the race. What you do is you measure that on a stopwatch, okay? Other examples are height. What you would do is measure someone's height. So that's how we classify data. Now, it's really important to be able to classify it, because once we classify it, that goes on to dictate how we actually can present the data, because there's certain graphs and charts and things like that that we can use on categorical data and certain things that we can use on numerical data. All right, so on to random sampling, and we just need to note that if I said think of a random number between 1 and 20, that number that you generate wouldn't be random, okay? It's got some bias to it. Whatever it is, it does have some bias. And the idea of think of a random number between does not generate a truly random number. And so if I was to choose 5 girls from this list of students here to be given $100, and I wanted to ensure that that was random, the way to do it wouldn't be like shut my eyes and go, all right, 4, 7, 6, and 15, and I don't know, 7. I think I just chose 7 twice. Anyway, it doesn't matter. That's not random, okay? So what you want to do is use your calculator to select 5 at random, and the instructions are here, okay? And so you're going to go to this keyboard and go down into this section here, go to the R functions, which are funnily enough under R, and we want rand list. All right, so what rand list asks for is 4 things, okay? It needs to know how many numbers you want to generate. It needs to know the lowest number you're willing to generate and the highest number you're willing to generate. So 5, 1, 19. And we hit enter on that, and there's my random list. Now notice that 10 was generated twice. So why don't we just change that to be 6 and take the first, well, this is not good because it's repeating numbers, but that's all right because it is random. Let's generate 8, 1, 2, 3, 4, 5, and take the first 5 that aren't repeated. There you go. Okay, so in my case, I would have had like 13, Montana, 8, Kaylee, 19, Molly, 18, Ellen, and 12, Annalise. All right, there's the list of students who got $100. All right, so who were the lucky winners? Write down who you got in yours. How is this different from choosing 5 numbers in your head? There's no bias whatsoever, okay? There's no favorite number. There's no tendency that if I've chosen 1 and 3, which are close together, I might think, oh, well, to be random, I need to choose something high. So I then choose 17, okay? Humans sort of think like that. And actually, if you want to see a good example of that in action, watch this number file clip about why we are not very good random number generators and how Simon Pampina actually finds a way to win lots and lots of money off people by getting them to think they generate random numbers. So it's a really good video, good viewing there.